Welcome everybody to Today in Space. My name is Alex Girofanos. I'm your host as always, and this week we're back for another segment of People of Science where we talk about someone that's in the field or used to be in the field or just people that have ended up in STEM in some way or another and use that scientific mindset in their everyday life. And this week we have Haley Harrison on with us today. Haley and I met at the CRS-19 NASA Social. We went for that SpaceX launch to resupply the International Space Station. It was amazing. And Haley's on to discuss what she's doing now with her PhD. Haley, welcome.
Thank you, Alex. It's been a long time, so I'm glad to finally have the opportunity to talk to you. So a little bit about me. So I am getting a PhD in nanoscience. I'm a doctoral candidate. Hopefully, I'll be finishing this summer. I have a bachelor's degree. Right, like write that dissertation.
Fingers crossed. I know that feeling all too well.
Yeah. Oh my God. I'm just like, it'll be done. I have a really good team. Like, I guess like I could talk about that too. Like having a good advisor versus having a not great advisor, because it makes
we totally should. And this is great. Like one of the things I wanted to talk to you about was obviously what you're trying to do with your PhD, but also like not many people, unless they know someone or they're going through it themselves, have any idea what going through a PhD, never mind in STEM, is like. So, let's talk about the PhD first, and I'm sure we'll get to having a good team because that is super, super important.
Yes. Okay, so we should talk about that. So my bachelor's degree is in physics, and my master's degree is in earth science. And so I work now with chemistry, and I'm always telling people I have taken Intro to Chem 1 and 2, and then I took like a nanochem class. But I don't have like a really strong chemistry background, but I definitely consider myself a chemist. I do a lot of chemistry now. So yeah, that's my background.
That's awesome. So I was terrible at chemistry and biology, and it's weird because like for someone that got into aerospace and looks at like the universe and how expansive it is, I mean the micro world is the same thing just in the other direction, really.
Right. Oh yeah.
And yeah, it's wild how like those two things, like even like orbits and atoms and orbits around stars, like there's a lot of similarity in that. So let's talk about physics, earth science, and then now nanoscience. First of all, how did you get to your bachelor's degree? How did you decide to get into STEM? Where did that all start? Was it as a kid or?
So, I mean, I always liked science, but, like I was the kid that like I had a rock collection and like I tried to give it to Sky. That's my daughter. And like when I tried to give it to her 2 years ago, she didn't want it. And she was like, this is lame. You're a nerd. But now she's like a little bit interested. But I mean, like I collected rocks. I was always into like categorizing and labeling. And so like that was just kind of always how I was doing things. But when I got into school, and like middle school, high school, you talk to people and they kind of start to tell you what you should be doing. And so like, even though I had these characteristics and it's like, oh yeah, you're categorizing, you're doing these things, that's science. People were telling me like art, language arts, you're not good at math. And so that kind of got to me. And I mean, like I talk about that all the time on Twitter. So, like how like the way people talk to us, it changes what the outcome of our careers are going to be. So when I started college, I actually was majoring in music performance, and I was studying flute performance. And so I took like an algebra class, and that algebra class at an all women's college was the first time I got an A in a math class. And it was algebra. I'd never taken calculus. And so after that, like the program got canceled and they said, oh, well, your whole degree program is gone. Find something.
Oh my God, the whole program for your degree got canceled? Oh my God.
So like, here's me like, yes, wow. I'm going to play flute like for the rest of my life. And they're like, try another school, try another state. And of course, like as that, this was 10, 11 years ago. And so at the time they were really pushing STEM, and these programs are getting smaller and smaller. And I mean, like, I couldn't afford to go to another private college.
Mm.
And so, like, it sucked. Like, the professor had tenure and all this stuff. And so they
Yeah.
kind of just got rid of them. And so I came back and started looking outside of art. And because I was
Mm.
very proud of myself, like, this sounds ridiculous, but like, I was so proud of myself for getting an A in like the algebra class. I was like, yeah, I think I could do math, right? So like, I'm like, I got an A in this algebra class. I think I can study, physics, right?
Mm.
And I mean, so like, even though I had like all of these people telling me not to like go into STEM, I really enjoy it. I read books about physics, so I understood what physics was
Mm.
fundamentally.
Yeah.
But I didn't have the fancy calculus classes at the time. So I went
Yeah.
to some state schools. I put in applications, and so I went to North Carolina Central University. So that's an HBCU in Durham. And the advisor was like, if you can pass these classes, so like in order to study physics, you have to take the classes. It doesn't matter if you've had them or
Mm.
not. At different schools, you can like get the calculus and the physics. Some schools want you to have taken all of those courses before you come in.
Right.
Right. So, but
Mm.
at this school, the HBCU, they exist to kind of level the playing field. So they'll offer you,
Mm.
a chance to take those classes. And if you can pass the classes, they were like, you can pursue the degree track. And so I decided to pursue the classes and follow the degree track. And I was successful with it. And
Sick.
so that's how I
That's
got
so
there, right?
cool.
Like, it's crazy because I
That
mean,
is
like,
crazy.
yeah, like looking back, it's like, well, how did you? Some people are like, yeah, I've always wanted to be a scientist. I was always good at math. And, even now I tell people all the time that if you're not good at math, I don't know what being good at math is. Like,
Right.
anyone can learn the tools for studying math. Anyone can learn the tools for calculus. Yes, people may be,
Hmm.
you know, quicker at it or better at it, but that
Sure.
doesn't mean that you can't, do it. And so I always think that's important to share with people because it's very help. It's going to be important as we move forward with kind of creating a background of having a nice, diverse STEM workforce.
Hmm.
You know.
No, absolutely. And I'm blown away because I had like a weird similar story where, I started in really music first. I like had a passion
Mm.
for science in like elementary school. Like we had a science teacher that would come in and do experiments, and I always loved that. But like I was I was like someone who drew. I thought I was going to go into architecture, and then
Yeah.
uh, you know, my freshman year of high school, my guidance counselor told me, you're not smart enough, you didn't get the grades, we're going to drop you down in both math and science. And I was just thinking I didn't
Wow.
even know any better. Yeah. So I didn't even know any better. I'm like, okay, great, I got easy classes, like I'm good. And then the first like month I was like, oh, this is not what I was looking for.
Right.
So I still have that chip on my shoulder. And it didn't get any easier when I went to college because I just didn't have
Yeah.
the skills, right? Like you're saying, like it's something you got to learn and you can do it, but you got to figure out how to do it quicker, or just for yourself, right? You don't have to be the person getting 100 on every exam. Like you don't have to be someone that can do something for them as in the workforce. Um, did you? Because this is interesting. Uh, between like music and them, was test taking an issue for you? Was that something
Oh
you had to
man.
learn?
So even like starting like in third grade,
Mm,
I was really bad at test taking. And so like I always have anxiety around test taking and like the whole
mm,
process. But
same.
yeah, so like I was just telling, so like I'm in the process of like trying to get diagnosed for ADHD. And I am
Oh,
28, right? So like a lot of adults now are like looking back like, well, I've had trouble with these things like processing, test taking, and focusing, and
Mm.
it comes to find out that you have, ADHD, test taking anxiety, and I mean, I was good enough at test taking, right? Like I know how to
Mm.
memorize. And of course, even if
Mm.
you know how to memorize things, like that is okay, you know, for English 101. But after you get out of even English 102, the next level of English class, that starts to fall apart. And so you
Right.
have to learn these things that our lovely education system doesn't really do a good job of teaching, right? So it's like you
Yeah.
have
Oh, totally.
SAT scores, right? You have these tests that are supposed to say you're smart enough to do this, you're smart
Mm.
enough to do that, and they're missing all these people who have,
Yeah.
these
Just different
different
ways of
skills.
learning, right? Yeah, like their
Right.
brains just work slightly differently, and it's so weird to think about now because I'm in the same boat. I'm 31, and now as I'm starting to see some influences of people online who are diagnosed, who talk about it, I'm like, that's
Right.
me. I was like, that was the exact same problem I had. Like I would go into a test and like I would cram. It was so stupid. I didn't know what I was doing, but I would like stay up all night. I would try to cram and do all these late night studying, and then I would go to the test, and it would just
Just gone.
disappear, gone. Like I hadn't even spent a second doing it, and it took me 2.5 years, 3 years before I even asked for help because I thought there was something wrong with me. I was like, am I not smart enough? Am I like, and so now in years later, I'm no longer having those dreams about I walked into a test and didn't study at all, though those will probably come back now that I talked about it. Yeah, it's crazy. So for me, it took me 7 years to finish my undergraduate. So the fact that you're in your PhD and you got your master's, like I have so much respect for that. Like especially knowing that we think the same way. Like
Right.
what was there? Okay, so with physics, you got those classes, you figured out what you needed to do. Was there? And let's talk about your team, right? Did that start before your PhD, or was that right around the PhD?
So yeah, I have a good team now, but when I started in undergrad, like they give you tools, but they don't really have a great team. You know, they
Mm,
they have who they, can get. So there was
right.
in undergrad, there was definitely a boys club. And
Mm,
so by the time, so it was hard in the beginning, but by the time I got to like my second and third year, the physics department, was recognizing like, we should do more to like look out for the women in the department. Because I was spending time hanging out with people who were in the biology major, in the pharmacy science major, because they would take some of those classes, and so I would be able to like kind of have more people who weren't so focused on like trying to gatekeep. But then by the time I was in the third year, we had more women in the physics department, and so the department decided to put us all in the classes together so that we could work together. And that,
mm,
like, it's really important because you have to break up, the monotony of seeing a class full of men, because even at an HBCU, classes are still going to be dominated by men, and they're still going to be dominated by white men. And people sometimes don't realize that those dynamics exist no matter where you go. And it's up to the professors, it's up to the faculty to try and support the people who aren't represented equally. So they tried their best, and I held on, and I had a lot of supportive people in the master's program, that would look out for me. And so that kind of helped me when I was ready to go to graduate school. There were people who were like, okay, so this is graduate school. At the time, you get a degree in physics, and so most people who get degrees in physics, they have always wanted to study physics, and they know that they have to get a PhD in physics.
right.
And I didn't really understand, all of that and what went into it.
Mm,
Um, and so I think that was a little bit more challenging because, even though I was like, oh, I can do this step, like getting into the physics department, getting a physics degree. There's so much more that people around me kind of knew a lot more about. And then,
Mm,
I didn't really kind of understand that. So I think that was
yeah.
probably a challenge.
Well, that's such a good advice for, I mean, we've got people that are, just deciding to get into STEM that are listening, or, haven't gotten into it yet and are trying to think about whether they should, or like, they got their undergraduate and maybe they want to go for their PhD, and like that, finding those people that can be on your team and learning the people side of academics. Like, so many of us
Yeah,
go into it like, oh, I want to learn the science and the math, but like knowing the secretary in the department is such a huge skill. Like, knowing the professor on like a name basis where they know you and you've gone to those, like, I didn't do that. So that's why I'm trying to talk about it so much. I didn't do that till so much later. I could have saved
right.
so much money and
Right? Like,
time.
see, that's how I
Like,
feel like
oh,
looking back.
yeah, it's crazy, and those things are so important. So I'm so glad that you're mentioning it. And as far as physics, yeah, I've got some friends that thought they were going to do PhD in physics, and then it didn't make sense. Like, they got to the point where it was like, oh, this isn't really what I want to do. And there's so many of us that do that we don't know until we get there, and then we've got this money bag of debt on our shoulders, and we're like, whoa, what am I doing? I don't like this anymore, or this doesn't, I liked it better there, or whatever it might be. So when did the switch to the PhD happen?
Right. So when I was finishing my undergraduate degree, I realized that in physics there are people who are experimentalists, and then there are people who
Mm,
are theorists, and then there are the people who do all of the programming.
mm,
And so at my school, they had people who were mostly doing a lot of the programming, and I hate programming. And so I
mm.
realized, like, if I was going to go into physics, I was going to have to master all of these programming languages.
It's like
And like that was,
MATLAB and all that stuff.
yeah,
Yeah, yeah,
MATLAB, what is that other one? I can't even remember now. But like it was used for this one like
yeah.
nuclear physics thing.
Right.
And like I didn't even realize, like that's another thing. I didn't even realize then that that was just like one language package. And like
Right.
there are other language packages that are, easier to work with, but
Mm.
I still don't like programming. So I
But you know
had
that. That's important.
Yeah, so I mean, I knew it. So I was looking at like, okay, so if I'm gonna get a job like after my degree, I would have to program. And
Mm,
like I was like, I don't want to program. I knew that that was the one thing I knew. And so one of our professors had he had a grant for scanning electron microscopy, so like the
mm,
big microscopes and what else was it? And so then I kind of learned that, the experimental side kind of bridged with all of these other kind of research subjects. So like they
mm.
were working with biologists, they were working with chemists, and you could, learn and understand phenomenon that was, on this nanoscale experimentally without programming a lot. And so that was really
That's
my
nice.
first time,
Yeah.
realizing that and kind of seeing that there were, you could use physics, but you don't have to, and you can kind of broaden your horizons, and having a physics background would be beneficial.
Mm.
And so that's kind of where that went for me, I think.
That's yeah, that's super important that you figured that out. I mean, yeah. And I don't know if this is helpful, but we're talking for so many people in this segment about what their journey was in STEM. I wonder if knowing more about the different jobs or like a specific thing that you could do with that degree is beneficial beforehand. I know it would have been for me. I mean, I took a college board survey. I'm not even sure if they even exist anymore, but it was like a personality survey. It was like, oh, you could fit into like aerospace or aeronautical. And I saw a picture of the space shuttle and I was like, oh, damn, I want to work on that. That's a job.
Right.
And so, like, that's why I went into it. But I had no idea what job I was going to do when I got out. So I kind of fumbled around for years trying to find what was useful. And it wasn't until I worked at an injection molding shop and got hands-on working with stuff and building, R&D molds for composites. Like that's when I was like, oh, I get this. Like this is cool. But
Right.
if I had stayed in school, I wouldn't have known. I wouldn't have, figured
Yeah.
any of that out. So okay, so physics. Let's keep going through here. When do you find your team?
Okay, so I find my team. So after my master's program, it was great. I got to collaborate with a lot of people. So then I'm currently at the Joint School of Nanoscience and Nanoengineering in Greensboro. So that program is supposed to be a collaborative effort between UNC Greensboro in North Carolina and North Carolina Agricultural and Technical State University, which is an engineering school. So when I came to the school, I was like, I reached out to one professor and I told her, at the time, I think she was like the head of the department. And so that's why I reached out to her. And I just told her, I was like, I like working in the lab, blah, 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 telling her like my skills. And so I knew that I had to have a higher GPA to get a PhD. So that's why I got the master's degree.
Okay.
That's still kind
Smart.
of important. Yeah, so I had to get the master's degree in order to qualify for funding and all of this other stuff. And so I was telling her that I like to work in the lab, and she was telling me about kind of the classes and the programs. And I told her about briefly, so like I didn't go into like a whole bunch. I tried to just like leave little like nuggets of like the issues I had with my master's department and kind of the things I was looking for. I wanted to do more hands-on research. I wanted to do more traveling. I saw that she had a grant with NASA, and I told her I was interested in applying for a fellowship with NASA. And she told me that she had space in her group, and she told me to apply. So
Awesome.
I applied, and so like, yeah, at the time, like, I didn't even realize that. So during this time, there was another colleague in my master's group who came before me, and she was helping me, because she had been through the process. If it weren't for her, I wouldn't know her. And then there was another guy that was also doing that, and they were helpful. So I knew like, okay, you have to write an email, you have to reach out to these people,
Right.
you have to be specific, and all these things that you need to know. And so like I would visited a bunch of campuses. I went to JSNN because I'm there, but I also visited Ohio State, Michigan State, like all these other places. Where else did I go? I went everywhere, just to like see what was out there. And it's good. Like
Right.
I recommend anyone, if you're an undergraduate or a master's student, apply for travel fellowships to visit graduate programs. They will pay for you to go. You can stay in a hotel, and it's great because you can talk to people who are smarter than you, who have a different background from you, and you can just like, it's just great to like tell them, hey, I want to do this, and they'll be like, yeah, you should do that. Think about this, and or you shouldn't do this. So I think that that's really important when people are choosing schools. Like, definitely go, and
Well,
if
and
you
that's
can
such a
get
good
some,
advice too.
yeah,
Sorry, it's such a good advice because like what it does that I don't think many people realize before is like it puts you into this like weird club of like people that are like, oh, you're like me, like let me tell you, like let's be friends. I can tell you about all these things, and like you don't even realize how many different experiences people have and what they can share. So like that's awesome. That's great advice. Thank you.
yes, I do it. So if whoever's watching, please, like, when you're in school, like, I'm really social. I don't admit it, but like I will call anyone. I will send an email. I will
Mm.
walk up to people, and I will just like talk to them and get their experience. So that was something that was good for me because coming out of a master's program and going into a PhD program, if you're gonna switch gears, because like if you look at all the things I've done, like I'm switching gears all the time, and so it doesn't really make sense. And so without background, I kind of have to give some information on to explain why, what's motivating, my choices.
Sure.
So yeah. Wait. Oh yeah. So I was talking about my team. Yes. So I'm almost there. So yeah, the application process.
This is all good. It's all good.
The application process is fun, but yeah. So after I got to my program, um, I realized that this professor, she's on my committee, but she's not my primary advisor. So after
Mm,
I started taking classes, I met another faculty member, and he's like, "So I do rocket science. Let's blow stuff up, aerospace."
yeah.
And I was like, "I like you, right?" And so like immediately, like, no hard feelings. I was like, "I'm gonna go work with this guy over here." And
Mm,
so he was a new faculty member, Dr. Austin, and at the time I was his only student. So
mm,
he was a new professor, and so like he was just starting up his lab, and I was a first year student in the PhD program, struggling
mm.
with the classes, because like in a lot of graduate school, everyone who goes to graduate school is struggling with classes their first year. I mean, everybody in college is struggling with
Yeah.
classes, so like everybody understands, like struggling, just like a mess. And I told this professor, I said, I want to work in the lab because I was having just such a hard time with the classes, and I was not bored, but it was just kind of demoralizing. And so I kind of wanted some inspiration. So I kind of looked up some things related to his research, and I said, "Can I work in the lab as a first year?" And he was like, "Sure, why not?" Right? And so I had, because I had some um, other advisors, I had also asked them, I asked them if I could work in the lab just to kind of help me get back into my element.
Sure.
And, they were like, no, you need to. So I didn't ask my other advisor. Ooh, hold on. I lost my, oh, there it goes. Let me make this window go away. Okay. So I talked to some other faculty members that were doing like small projects to see if I could just like do something.
Mm,
And they were like, no, you need to have your grades, you need to do this. And I was like, I don't want to. Like, I'm having a hard time. I want to do something
right.
else. And, so he was the only one that was like, yes, go in the lab right now. Here's what I need done. And so like he just had this small project he needed to tie up from his postdoc.
Mm,
And I was like, okay.
okay.
So I just started spending a lot of time, my free time, if I was having a hard time studying, in the lab. And when you get into the lab, it's a great opportunity to learn skills. So if there was something that I was unfamiliar with, I would just practice. I would ask for help, and I would just spend time working on these things. And, people would be like, shouldn't you be studying? And I was like,
I am.
I think I'm studying, so like into that first year, he was the only one that was kind of encouraging, get in the lab, let's get this data out, let's do this.
Mm,
And so at the time, that's what I needed. That's what helped me get through the first year. It was very
mm,
hard. And it wasn't just hard for me, it was hard for all of us. All of us were struggling. And so at the end of the first year, into the second year, I had began working on publication. And, when you're in academia, when you're taking all these classes, what people want to see is publications. So it was good for me. And that just turned out to be a really a great person for me to be working with, at that time to keep me motivated. Um, as I was getting out of the trenches in grad school before you get to the
yeah.
fun part when they say you're supposed to be, in the lab. So,
Mm,
but one other thing I will say is that, they want you to focus on classes and it's very important, but people will obviously, they want you to, work on your project. They want you to follow your passions. So if you're someone that is doing well in your classes, obviously you should kind of emphasize that. But if you want something different, it's okay to like go out and seek other faculty members who will be willing to help you grow as a scientist or engineer.
absolutely. And going back to just ADHD and thinking just our brains working differently. Like maybe if you knew at that time, you could have been like, hey, look, like I have to be hands-on. For me, I kind of fell on it while I was finishing up my school. I was working full time, doing school part time, and I had enough money to buy a 3D printer. And then that's like when I was tinkering, and I was like, ooh, I really like this, and
Yeah.
like it got my. You said something about like it being demoralizing. As soon as you said that, it brought me back. That was the exact same feeling I had because it was like spending all this time doing something that just doesn't seem to be clicking in my head, and you're in graduate school, like you're in the top echelon of people who have brains, who are smart, but we
Right.
in academia put ourselves on a curve that makes no sense. It's like we all should be there. We all
Right.
should be there. And it's like, just because you may sit on a certain side of the curve, it doesn't mean that you're dumb. It just means like you don't fit in this system that was built
Right.
before you got here. And like, so I fought that system for so long until I decided I was just gonna find what worked for me. And that's so cool that you took the initiative to say, hey, no, I want to do something else, and you gave yourself enough numbers that you got a success, right? You didn't just talk to one professor, right? You talked to everyone that you could, basically. Like that's a great way to go about that.
Yeah. Yeah, so, and I like to tell people that, you shouldn't be intimidated by professors, because if you're going into academia, maybe you want to be a professor. And so you
Mm.
should be comfortable talking to them, and they should be comfortable talking to you. And, I don't know. There's so many things about like navigating within academia and like realizing who is going to be an ally towards you. Like someone was telling me, like when you're looking for an advisor, it's almost like, going on a date. Not really, but like you want to get to know someone and know if they're going to help you or if they're going to
Mm.
hurt you, right? If they are
Mm.
compatible with you, if there's someone who is really hands-on, because some students like to check in with their advisor every day. And some
Mhm.
professors need you to check in every day. Some advisors are going to be more hands off. And so if you're
Mhm.
someone that needs to be checked in often and your advisor's hands off, that's not going to work for you. And so talking to all of the professors in your department, talking to the students about, the troubles that you're having will help save time for everyone, in the long run,
Absolutely.
when you're looking for, a 5-year, 6-year project that you're working on.
Yeah. That couldn't say that any better. So let's talk about that fellowship and like, can you talk about any of the stuff that you like? What does hands-on work look like for someone in nanoscience? I know what it looks like for me, but I'm sure it's a little different. Like every lab, it's not just beakers, right? Necessarily. Like what
Yes.
was in that
So,
lab? What were you working on?
okay. So when I first came in, and I was talking to my advisor, we worked on applying. For me, I worked on applying for a NASA fellowship. I did not get the fellowship, but it's okay because it was really important for me, in my career trajectory. When you have an advisor who's willing to help you and get you in front of the people who are important, it can help motivate you even when you're rejected all the time. So tell everyone, there are rejections, but there are good things that come out of them. So during my PhD, I work in a wet chemistry lab and I work with beakers. I
Yeah.
work, so it's like I have
Yeah.
that standard lab, pouring liquids and using pipettes and,
Pipettes. Yeah.
yeah, so
Awesome.
that's kind of the lab that I work in, but I've worked in other labs where they don't have the wet chemistry, just have
Mm.
big tools and just like you press
Yeah.
buttons. But definitely I'm more familiar with the chemistry side, which is surprising, of course. Um, and then so I've also worked with polymer chemistry, and so it's the same kind of lab, with the
Mm.
beakers and everyone's wearing the lab coats. And we have, so in our lab at school, we built a supercritical pressure chamber for drying our aerogels. So it's a manual system. And so like we've got, it looks like more of an engineering kind of lab. You've got wrenches and tools and, big oxygen tanks and stuff like that. So all within the same space we're doing, because so like we've got scientists and then, I don't, engineers, and then people who are doing engineering science, I think is the appropriate term,
Okay.
within the same lab. And so then you've got, the glove boxes. So like I work with nanomaterials, and so it's just powder. It looks like powder. Hold on, I'll be right back. I have some
No.
nanotubes.
Oh.
So, I don't know. The company doesn't consent to being on the video, but so I'm gonna try and like cover it. But if it shows, I
Okay.
guess you could just.
I could blur it too.
So,
Yeah.
oh, hold on. Okay, so this is boron nitride nanotubes. So this is kind of what the material looks like. It's purified. It's bright white. This is kind of what I work with. The funny thing about, right? Everyone is, I think most people are familiar with carbon nanotubes, the black stuff.
Yep.
So like this is the opposite, and it's cooler.
And so from a nano perspective, what's the advantage of doing something like this in that nanotube shape for that material? Like, what is the problem, or like what is it trying to do that you couldn't do otherwise before nanoscience?
Well, okay, so let's see if I can kind of answer this. So
Dance around not revealing what it is.
So the nanotubes are they just look like long skinny fibers, and they're really strong. They have piezoelectric properties, so they can kind of generate energy with mechanical force. They're radiation shielding. Let's see. They have interesting optical properties because they're white that carbon nanotubes don't have. And then they resist oxidation up until like 800 degrees Celsius. So when we're looking at, so that's why like the whole aerospace, is interesting, because they're always trying to heat stuff up. You've got, systems that you want to thermally protect. So that's kind of always our pitch. But when you synthesize the tubes, because they have these forces, these really strong forces that just draw them together, the fibers just come together into this fluff ball. And so it looks interesting, but it's really useless like that. And so all of our work, I spent lots and lots of time, learning and figuring out new ways to separate the tubes and use them and make them functionalized. So like that's just simple fundamental surface chemistry, fundamental studies of studying how they perform, in solution. And, just working with simple functionalization, just trying to add small groups to the tube surfaces. And then, of course, so those are the tubes, and then you have platelets, and then you have powders, and then sheets. So they're just shaped differently, and then they're just nano-sized. And so that we can put them into solution, and then instead of they come together. They just you put them into solution. They come together and then they fall out of solution. And so we're just trying to study how to keep them in solution without falling. We're trying to study how to put them into other materials. Some people work with putting them into high density materials, polymers, metals, composites, ceramics. And I've been working on putting them into low density materials. So that we can, so you can have that multifunctionality. There go those keywords. The multifunctionality. So you want them to be, lightweight, but really strong, lightweight, radiation shielding, and kind of, improve those properties that way.
All right. I mean, and what you're doing, and correct me if I'm wrong, but it sounds like you're really on the like pioneering front end of like, we have all these properties that we like, but we haven't figured out how to do that yet. So you're just like poking it and being like, okay, what does it do now? Is that good? Okay, now what are you looking for?
Yeah, no, and like honestly, when I first started, I would talk to people and tell them like kind of, what I was doing, and they were like, I was like, oh yeah, I'm just, making a calibration curve. I'm studying, the concentration of the material in solution. And they're like, why is your advisor's making you do that? Oh, is that just like a test? I'm like, no one's done it.
Right.
Like, nobody's done it yet. So
Hmm.
where I think it's cool and I think it's interesting, so that's good for me. Some people
Right.
aren't interested in this kind of stuff because it just feels like it's not as cutting edge and it's not as like big and dramatic. So,
Well, I'm glad you said that because like it's interesting. What I hope for everyone that gets into STEM is that they find the thing that brings them so much joy that, like with any job, there's going to be bullshit that you deal with, and you've
mhm,
got to find the thing that brings you joy. That all that stuff doesn't matter, right?
right.
So like for you, pioneering like and poking things at a nano level is like for you. Like for me, it's would be okay. I'm using plastics, but I don't know. I'm not, for 3D printing stuff. Like I am more concerned with um, how I'm going to be able to apply the thing that was created from that. I don't necessarily need to know the chemical formula or the balance or, that to me is not. I'm just not good at it. Like I said, I was terrible at biology and chemistry, mostly because like I couldn't get hands on with it. I didn't understand. It was all super visual, like the orbits of an electron or um, even chemical equations. Like I maybe it was just the time I grew up in. Like there wasn't a lot of that stuff out there. But I'm just glad to hear that you found something that you like. Like that's the most important thing for anyone that gets into STEM is like taste, like try things for sure, but then
Yes.
at a certain point you've got to focus on what do you want to do. So that's super cool.
Oh yeah, definitely. Because there's so many things, and like I respect everyone's like choices because I work with lots and lots of different people who are good at different things. So like when you're
Mm,
talking about 3D printing, there's people in my group now. So my group now is not just me and my advisor. There's other people. And so they're working with cellulose, they're working with other fibers, and I don't know a lot about their projects to talk on it, but they're doing all sorts of other things. And so you've got people
mm,
who are doing 3D printing, and I probably will never be a 3D printing expert, but like I could still collaborate with people who are working on that.
right,
And you
right.
bring what I can do to what you can do and like make a totally new project, a new material,
Hmm.
you know? And so I think that
Hmm.
that's really, really valuable.
Yeah, and finding, we talk about the STEM workforce and it
Yeah.
diverse and always in who you are, but also like how you think. Like that's super important. But then, and I've seen this with academia being an issue, um, where working on a team is not, or working with people that don't think the same way as you, that is something that's not, and I don't know if it's still the case, but when I was there, it didn't seem like it, and maybe I was just jaded, and that's exactly what I was looking for, and that's what I found. But I found that working together on a team, I found more of in the workforce than I did inside of a lab doing the same thing. That was my experience.
Yeah.
What is it? What is it? It sounds like you have that team, which is great. I'm so happy to hear that.
Yeah, so like at my school, that's supposed to be like the whole thing. It's supposed to be
Mm,
interdisciplinary and you're supposed to collaborate and work on a team. So I'm
mm,
lucky in that regard where my advisor really values that and you see the power that comes out of those collaborations. Um, because it's even in so academia, I don't want to be a professor, but I'm not going to talk, bad about academia, but to criticize it, it's shown as a world where, especially when you're getting the degree, you're supposed to be working against your classmates. And so
mm.
people who have different skills may, think less of other people who have, other research things like, oh, well, that's not real chemistry or that's not real engineering or that they're not really a part of the department. So, I mean, I've seen that. And I think that you can't like yeah in industry, that's why I like when I work with companies, like it helps you get out there
Mm.
and see that like people will be like, oh, I don't know how to do that, you help me figure that out. And it's like, but I can help you right with this. And so like the only
Right.
way that you get past your like my little project by itself is meaningless. In order to make some of these things I've worked on go anywhere, I have to talk to people who know things I do not know. Like,
Right.
you know,
Right.
learning learning polymer chemistry, I have to sit side by side with a polymer chemist and not be afraid to have my feelings hurt when I'm explaining, like A polymer, and they're like, that's not, how you do that. Like, you have to
Yeah.
just be around people who are going to like allow that. And then also you have to be
Mm.
willing to put yourself out there and like really collaborate and get in the weeds and make those like mistakes to get anywhere.
Yeah. No, absolutely. No, it's interesting. I spent so many years upset with the just the roll of the dice I had in school, just because things didn't work for so long. And the cool thing about this podcast is I've been able to talk to so many different people and meet so many different people, many who are
Yeah.
still in academia, and like it's helped me work through that and realize like the problem you discussed, right? Like of like people saying, "Oh, well, that's not real science." Like that, I think is a problem that's solvable, right? Like
Yeah.
it's not like oh they're screwed and they'll never fix it. Like I think that's a solvable problem, and I like the way that you brought it up, like to like add a critique. Like that's we have to be able. It's that's the scientific process, right? Like that's like if something's not working, you've got to say, well, okay, how do we can we change this? Can we do that better? Like that's the whole thing about like with nanoscience, right? That is the whole thing of like, well, the materials we have right now don't give us what
Hmm.
we want. Can we mess with the atoms to have a combination that gives us one property, or like you were describing, like all of those properties? Like everyone's going, yeah, we want that. let's let's let's
Yeah.
let's do that. Can you do more?
Oh, exactly. Yeah.
Yeah. So let me ask, because I think not many people get asked this question, but what do you want to do with your career? Like you get your PhD, you done. It's finally over. Have you even like taken a second to think about like where you want to go with this?
I don't know. And
That's
it's
okay,
like, okay,
but that's okay.
when do you decide? So I don't want to be a professor, but I don't like, I don't not ever want to, because I think it's important to like kind of be a mentor. But
Yeah.
so when I first started, I thought that there was more freedom in academia for research.
Mm,
But I think that, kind of working quickly, solving a lot of problems, might be an industry thing. And I think that, I'm going to apply for postdocs, and I'm going to kind of pursue that career path, and of course, if you don't
mm,
get postdocs, it's not guaranteed. But I'm going to pursue that research career track. But I
mm.
also do want to kind of pursue like the industry side. So, maybe that would mean for me stepping away from the lab bench and like working in a manager position or something. But I'm willing
I
to
will say there's
investigate.
still. I'm sorry. Go ahead.
Oh, go ahead. Yeah, I'm done. That was the last, I think, the last.
No, no. I just I can tell you from working in the industry, there's definitely lab benches. There's definitely that kind of opportunity out there. Um, what was interesting was it wasn't in an area like for me, it wasn't in an area that I thought it would be, but it was actually in tech. Like I didn't realize that
Yeah.
the variety and the amount of problems that I wanted to solve, it ended up being there. It, you know, manufacturing, I really liked, and I guess I'm still technically in manufacturing. But if you had to call what the culture was, it's tech. Um, so I think I think there's a lot there. I can say, and I'm not trying to pull you into 3D printing, but as far as 3D printing is concerned, like they haven't even begun. Like to take it from an aerospace specific example, like uh, metallurgy and all of the grain technology for whatever, I guess let's call it that, like what they were able to get from the early aerospace days, from castings, like those properties are above and beyond what you want for success, right? So they go above and beyond. We want to make sure there's a huge margin so that if something does happen, the stress or strain of what's going on doesn't just rip this thing apart, right? We don't want that
Right.
if we're traveling through space or flying people around every day. And I think a big limitation in 3D printing right now is a lack of the ability to control those grain structures. Like the boundaries between the layers is such a limiting factor that, great, you can get grain structures within a bead of material, but your biggest failure is between the layers. And finding that, they still have a long way to go to figure that out.
Oh yeah.
So as far as a nanoscience perspective, there is a lot there. And that's not even discussing, bio 3D printing. They're able to 3D print a heart that functions like a heart. I wouldn't put it in my body, but it's kind of there, right? They're almost there. But if they can figure out how to really dial it in at that nano scale, it's gonna be insane.
Yeah. Oh yeah. No, I've heard a lot more people have been talking about 3D printing lately. And so I don't know. I think that the last time I worked with a 3D printer, I was probably in undergrad. And so even just thinking from back then and what they were printing, they had
Oh yeah.
the little plastic, and it was just printing they weren't even, I don't know if they were 3D printing actual things. They were just printing lines and
Yeah.
squares and stuff like that. And so now you can program the 3D printers to print all sorts of stuff. I've seen crazy stuff. I would look into it for myself, especially I'm learning about injection molding and all of these other things, working with polymers, 3D printing polymers. So yeah, I mean, I am down. I'm applying for all sorts of stuff, because I mean, I like working with boron nitride, but more than that, I like working with the materials. So, that's definitely.
Yeah. No, and that's interesting because, I don't know, this has been cool to talk to so many different people in so many different disciplines. And it is, at least the thing that drives me is okay, what's the next thing that I can work on that I can just dive into? And I think it's good for people to know, there are some jobs or some paths that you're gonna just do the same thing every single day, and you have to ask, is that what you're looking for?
Right.
But yeah, no, that's that's incredible. So talking about more on kind of the aerospace level, you're already kind of playing with, you've been to NASA Social, the NASA Fellowship, all these things. Your phone case has NASA on the back.
Yeah.
Clearly, yeah. So, what is coming up here in the next decade from a space perspective in so many different aspects? I think nanoscience has a place, and maybe we can play with some ideas here. For me, I think structures, I think there's a huge benefit for this. I was looking up this before, even at a medical level. Nanoscience at a medical level, nanotechnology being able to be, implanted in the body or even in the bloodstream to monitor. I mean, as far as astronauts living on a moon colony, a Martian colony, I think those might become really important, because either you have to send someone up there that's the medic that then has all the equipment that can do all the testing, or you've got to have someone monitoring back on Earth. And I'm not sure what the easy way is. Is there anything exciting from a future perspective? Maybe it doesn't exist yet, but of where you see nanoscience being really valuable in space coming in the future here, when we're going to be sending humans all over the place?
Oh yeah. I think there are so many ways. If we can get, so carbon is a little more evolved. They've got a 20-year head start on the boron nitride nanotube, and then there's all sorts of other nanostructures. So as far as biologically, you've got, people exploring, molecular machines. So they're working with, so these aren't robots that are in the normal sense, but they are encoded with DNA or a biological system, and they are teaching them to go into the body and perform different actions. And then If they're safe to be in the body, they stay. If they are not safe, they are eliminated. And so people have been working with, I think, nanoparticles that are biologically safe. So you've got gold systems, silver, and they perform certain functions, and then they have to make sure that they are safe and they're eliminated from the body. And then so like that's biological. There's so much. Immunology is huge for nano. Vaccines is huge for nano. And then so outside of the biological, and then of course like the fibers, the nanofibers that they're using,
Right.
like cellulose, they do some low density materials work with the cellulose. And then of course you've got materials. So fibers for like spacesuits, if you want to kind of make them flexible, make them lightweight, because I mean right now the spacesuits have to be really thick to be protective. So nanomaterials such as boron nitride, if you can figure out how to spin them into a fiber that's long enough and strong enough, it could be, used to provide strength, radiation shielding, and be thinner than some of the materials that they're using. Then you've got structural. So you want to use them as structural reinforcement to reduce the weight of the component. So you could find there are so many different ways, and they're even using them now in, what do they call them? In their heat shielding technology, they use the carbon fibers, and they've got this crazy patent. I was looking at it, it's been a while, of how they like use the carbon nanotubes, and they are so lightweight, but they're so much stronger in their heat shields in those different materials structurally. So I mean, like they could go. There's so many ways. And then, so one other thing I think is interesting is using nanomaterials in like deflatable heat shields. So like when we're going to Mars and going to Venus, if you want to have something that's going to take up a little bit of space so that they have room for all those special components and the little satellites and stuff. What is the what's that thing that's on Mars? What's it called?
Oh, the Perseverance rover?
Yeah, the rover. Okay, I couldn't remember the word rover. I was like, it's not a satellite. It's not a robot. That's not what I was looking for.
I got you. I didn't want to say it too soon, but I knew exactly what you were trying to say.
You're like, yeah, see, it's not live because Haley's gonna forget a word. That's really easy. Okay. So when they send the rovers to Mars and Venus, if they're gonna have the heat shields and they want to make them deflatable, that's a great opportunity to use nanomaterials because they are ultra lightweight. You can put them, hopefully, you can put them into all these different materials. So they're looking at like braidable fibers. We're looking at inflatable and deflatable aerogels and all sorts of things like that. So that would be, that's just scratching the surface, any sort of application that you can think of. You can put nanomaterials in it.
Yeah. I'm thinking Bigelow Aerospace, like right away, like they're already testing inflatable spacecraft. I think they have one already on the space station right now. Yeah, they would love that. And I wanted to ask you this: at the nanoscale, is the presence of gravity a large enough force that it's an impeding thing in whatever you're trying to build, or in a nanostructure? Does that come into play, or is everything so small that it kind of doesn't make a difference? So, for instance, if you were going to build nanotechnology in orbit with the lack of gravity, would that help?
I don't know. That's a really good question. I have worked so when I did work with carbon nanotubes, there was no control for gravity, but like we just controlled like the static environment and we removed like the oxygen. It was, I guess, a standard glove box. I'm sure that somebody knows the answer to that, but I
Hmm.
don't know off the top of
No,
my
no,
head.
but it's interesting. Yeah, it's good to know that you guys aren't even considering it, because that means then probably it's not a big issue. I think from what I've
Yeah,
learned about nanotube over the years, carbon nanotubes specifically, is like I think the biggest challenge is developing it at a scale, like a size, manufacturing wise, that then it becomes, efficient, and people can be like, okay,
right.
I'll give you X amount of money to build this thing. Um, it seems like there's a limitation from how big you can make something out of carbon nanotubes right now.
Oh
Is
yeah.
that still it's still the case, right? Okay.
Yeah,
Do,
yeah.
do
So
we
I mean
know
it's
what the issues is there?
so for carbon, I think it's still cost. It's still
Okay.
cost. It's just like
Okay.
expensive. It's getting better to manufacture. And of course, like if you're going to make a product, we're not talking like gram scale. We're talking about maybe hundreds of grams, hundreds of thousands.
Right.
So like a lot of the time, so like even when I'm just working with boron nitride, it costs, you know, a lot of money, and then you get just like I don't know how much. Like it's over $100, $200, and you get like half a gram. And so
Wow.
like I can do a few experiments with that, but even, I take that to a company, I go, to the company and I'm like, "Hey, I want to put nanomaterials in your machine." And they're going to be like, "I can do that. It's already tested and proven for a fraction of the cost."
Yeah.
So it's like
Yeah.
a fraction of the cost. I don't need special glove box. I don't need this. So,
Right.
getting that there is still like that's why a lot of the space companies, like a lot of technology uses nanomaterials, but the space
Mm.
companies may or may not be like, we don't need to spend time or money on those sorts of, you know.
Right. No, absolutely. And I think, I mean, that's the same in any field. I mean, even 3D printing, and there's a lot of 3D printing right now that's still um, in the academic phase of things. I think so many things jump. They go from the academic, the labs, and then someone takes it and goes, okay, how do we go the next step with this?
Hmm.
Metals in 3D printing is starting to jump out of the labs and into um, actual manufacturing environments. But yeah, like to your point, if you were gonna, make just say a fixture for something inside of a rocket holding, let's just say, propellant to the side of the rocket, you're probably gonna machine that out of a solid block of something that was forged, because that's you're going to be able to do that cheaper than if you 3D printed it. Um, it's interesting how much of that is such a big deal and how much progress we have with things.
Yeah,
It's pretty wild.
yeah.
But yeah, I mean, Haley, thank you so much. We're basically at a time here.
Oh yeah.
Um,
Wow.
First of all, that went by. It's so good catching up with you. What do you have to kind of last thoughts for people? Thank you for sharing everything about your story, and yeah,
Yeah.
what are your last thoughts for folks?
So my last thoughts, I will say, go after whatever it is that, you want to do. Be ambitious. And, for me, I am not like ashamed of my story and like my grades, and I share it because I want people who may be less outgoing and, a little more sensitive to understand that you can be in my same situation and still have a good, career inside of academia. Because definitely, I talk to high school students, I talk to undergraduates, and someone in their life has said, you can't be a professor, you can't be a scientist if you do this one strange thing that they do. And then it can be discouraging for them. And then they see people who are just a little bit quirky, a little bit goofy, and just a little bit different, and that can encourage them, you know, a lot. So I mean, like I don't mind sharing, my story, and I encourage everyone to also share your story, um, because it's helpful to get the word out. And thank you for it's been like this year has been crazy. Thank you for having me on the podcast. We've been talking about
Absolutely.
this for
For a
a
while.
long time. And, I can't wait until we can go back in the world and see rocket launches again.
Oh,
So,
I can't wait for that.
like,
I can't wait for that. No, you. Thank you for coming on and sharing your story. Blown away. I remember when we went out for drinks after, what was it, the first day? It was
yeah.
before we saw the rocket launch. That was such a cool, like, just excursion. We were like, all right, let's go to this bar and drink and like hang out. And like we got to like know each other a lot more. It was just such a cool, like
Yeah,
NASA did such a great job with that. It was such a unique like group of people. And
exactly.
yeah, I can't wait to go back and do another one of those.
Yeah, it's so
But
cool.
thank you for coming on, sharing your story, and yeah, as always, everyone spread love and spread science. Ailey, best of luck with getting your PhD finalized and completed. I didn't even ask you. Um, are you? So I know there's different paths for PhDs. Which one are you? Are you doing a thesis or like how are you doing it?
So yes, I'm writing my thesis, based
It's
on,
brutal.
so, some of, so, all of the research that I've done. So hold on one second. I'm sorry. I don't remember what we were talking about.
No worries. We were talking about your thesis.
Oh yeah. Okay. So yes. So yeah. So I'm doing a thesis. Um, so when I write my thesis, you can either just like do like a whole thesis based on all of your research projects and then the conclusions. Well, no, the hypothesis that you came with when you wrote your proposal. So hopefully I will be done with that soon.
We're rooting for you. We're rooting for you over here, man. It's
Yeah.
it's a lot of work.
Yeah.
I've seen my friends go through it. Crazy.
I didn't, I've heard people talk about how bad it is and like, being in your last year and like still getting experiments because it's like you've said this, this, and this, and it's like
Mm,
this isn't good enough. You need to have a little bit more. And so it's like I'm in the trenches still,
yeah.
trying to get some last data. But like I said, I have a good advisor. Everyone is being very helpful even though it's a pandemic. Like, oh my gosh, it's a pandemic. Like, what is going
Dude,
on? So,
it's still raging. It's still raging.
yeah,
I
yeah, and
know.
it's
It's crazy.
still going on. Hey, it's
How has
crazy.
that
And
changed? I know I'm asking more questions that we were going to finish, but how has that changed? Like, how is that? It's obviously made your, you know, PhD a little more difficult to do. Um, is there anything like significant that was like, oh my God, how am I going to do this?
yeah, so, this last year, I was working with polymer aerogels, and so I was spending a little bit of time at NASA Glenn because they have a polymer aerogel group, and I can't go there. And I
Ah,
can't go. So even though my lab is open, I'm homeschooling Sky, and she's in first grade. So I have been trying to just like have a normal schedule and like taking all of those big ideas, that I had a year ago, and I was like, I'm gonna make these aerogels, and it's like you can't make any of those aerogels. I don't have the system. I don't have the background. I can't do that,
right.
on my own. So I've had to change my project and kind of like take that big chunk of the research that I kind of wanted to do out. And so it's a
Mm,
little sad, but
yeah,
you have to adjust and kind of
absolutely.
so based on working on just what I can do at my lab, based on what I can do with limited lab time, the things that I can have other researchers help me with. And of course, it's good if I publish any of that, my colleagues are going to get published too. So yeah, it's actually been, not fun,
Yeah.
but resolving network issues. Oh,
Oh, I can still see
um,
you.
okay, good.
Yeah.
I get so distracted. Like every time something
Oh
pops
yeah.
up, I have to give it my total attention. And Zoom is so
Yeah.
bad.
Yeah.
Like, so, but yeah, I mean, because I think, some people and some people are really having a hard time. And so like I always want,
Mm.
to be compassionate. But for me, I've been having a hard time, but it's not so bad. I've had other opportunities. Um, I've worked in other labs and, I've had some more hands-on experience and I'm still going to finish. Ultimately, my advisor is helpful in that he is understanding and like, you can't, these conclusions are not going to happen. You're going to have to do something different. And so
Right.
having that person tell you that this is okay and we're going to just
Mm.
adjust and keep moving forward, when you feel like working on in grad school can be very isolating, but when you feel like it's not good enough to have people around you that are saying this is still good enough and you're still going to finish, it makes a world of difference. So,
Yeah, absolutely. Absolutely.
yeah.
No, and that's what it's about. I mean, we've all in our own all of our own ways, we've all hit the wall where it's like, okay, whatever the world was before is not that now. And like
Oh,
I
yeah.
making the change as quickly as possible, I think is the most important thing, and it sucks. I mean, I've been through so many changes. I've lost jobs. I've gotten new jobs. Like yeah, it's been a crazy year. But like you said, like I know there's plenty of people that have had worse. So yeah, it's just keeping your head above water and just one of the weird things is the fact that there's a pandemic has given me the excuse to be like, yeah, you know what? All the stress I'm having about what should be, the FOMO, like I'm just like, yeah, but there's the whole world is
Yeah, the whole
is going
world.
through this. So yeah, we're all like I think it's okay if it takes like another week. I think it's fine.
Right. Yeah. Yeah,
Yeah,
another week, another 2 months. Me writing my dissertation. It'll be done in a week,
it'll be
a
done.
month, 3 months later. Yeah.
Well, Haley, I've kept you long enough, but thank you so much for coming on.
Yeah,
Thank you
no,
for sharing your
thanks for
story.
having me. Yeah.
Absolutely, absolutely. And that's it, folks. Thank you for joining us. Thank you, Haley, again for joining us. And spread love and spread science. Be well, and we'll see you in the next episode of Today in Space.